in the wrong direction. Right. Right. So another technologies that have been in use for some time in businesses, but they are technologies, so we'll talk about them, is identity and time management systems. So all these systems that we use to when you come to your workplace and you want to check in, to sign in, right? This has been there forever. So I don't think I'm going to talk a lot about this. I'm sure most of you know them. So instead of having to sign paper like people still do in some countries, all you have to do is maybe enter a passcode on a device, or maybe use your finger print, or maybe use your face recognition. So all of these are tools that are used to make sure the right person is arriving at the right location, right? So when to authenticate you, to make sure you are the right person coming into your workplace, or even using a PC at your job, there are three main ways that that technology use in order to authenticate you. Okay, so if you are looking security has different parts. Okay, so the two major, when you log into your computer, there are two things that happen. First thing is called authentication, and the second thing is called authorization. Okay, so authentication has to make sure you are the person you claim to be, right? So if I am using this computer, then I use my fingerprint so that the computer recognizes that I am Mohammed, the owner of the computer, and it opens up for me. Okay, so this is called authentication. The other part is called authorization, right? Authorization means, okay, I am Mohammed, right? But I'm not the administrator of this computer. So there are things that I cannot do on the computer. Okay. So authentication has to do with verifying my identity. Authorization has to do with verifying the jobs or the tasks I can do on this computer. Okay. So these are two different things. Okay. So authentication is the first thing we will talk about here. There are different concepts or different directions in authentication. The first one is using something that the user knows. So using a password or a PIN code, something like that, something that only you know, like passwords, right? Another thing is using something a user possesses, right? Most of you will not be familiar with this, but in some banks and for some sophisticated systems, not even that, even now, right? You will be using it at CSUMB. They send you authorization code on your phone, right? So you don't have to have a password anymore. They send you an authorization code on your phone. You enter this code into the system and you are able to log in, or you press a button on your phone and you can log in, right? So this is something a user possesses. This is one of the newest technologies used to authenticate users into a system. And then there are something that is unique part of the user. So this is something like face recognition or fingerprinting. Okay, so this is a third way to authenticate the users. Right now, I think it's mostly people are going towards this second, especially big systems, right? Systems that are sensitive, they are going towards this second option, something that the user possesses. So they use they use authentication applications on your phones. I think CSUMB is going this way, right? So biometrics is something that you own. So biometrics means your fingerprints, your facial recognition, retina, and all of these steps. Okay. Okay. Another very old and very common technology right now is RFID, or radio frequency identification. RFID are this, when you go to a store and you find these small chips on the clothes you are buying. Okay, these are called RFID chips. Okay, they work in a very similar way to Wi-Fi, like the Wi-Fi network that we use. They work in the same way. So you hang up these small tags to clothes or to products or to whatever, and then there are readers inside the company or inside the store or inside warehouse. Okay, And these readers will read the content out of these chips and find and tell you where they are, tell you some information about these chips and so on. Okay. RFIDs are very common in many industries. Okay. Amazon, for example, Amazon warehouses, they use RFID to identify the location of different products. So if a worker in Amazon wants to reach smartphones, Samsung smartphone S21 or whatever, then there is an RFID tag on this phone. All the user or the worker has to do is to read this RFID, and it will tell them all the information they need, right? So RFID are small chips that are attached to objects like products, and there are readers that can read the content of these chips and identify them. Okay. Very similar to Wi-Fi, but with smaller range, right? Now, as I mentioned, the biggest area where this is used is warehouses. It's used in most big warehouses. Walmart uses them, Amazon uses them, and other areas as well. Okay. There are this technology existed forever, but there are always innovative uses of the technology, right? So there is a difference between the technology and how you use it, right? So a project I worked in that uses RFID is to track newborn kids in hospitals. Okay, that wasn't in the US; it was in a different country, and they had a problem one time. Someone went into the young kids place where newborn area in the hospital, and they stole some baby. They kidnapped a baby, so they wanted to secure this. So what happened is we created an RFID system with readers inside the hospital, and we attached RFID chips to the kid, to the newborn, and to the mother, right? So as long as the newborn was with her mother, everything was okay. If they are separated and the newborn is moving outside the hospital, we would get an alarm, right? Yeah, could be, right? So could be in hospitals means someone is kidnapped, I think, right? So
typically,
yeah, right. So it's an old technology that is used in stores and warehouses, but we used it in a different context. We used it inside a hospital to secure the kids there. So again, this is a way to use disruptive technologies. Right? Okay. All right. All right. Sensor technology. So sensor networks. Okay. So let me. I want this to be approachable to you as possible. So you know Fitbits, right? So everyone has, not everyone, but you know Fitbits and all of these wearable devices that you put into your hand and measure your heart rate, your activities, your movement, and so on. And even your phone has lots of sensors. It has GPS sensor, it has attitude sensor, it has direction sensor, and so many sensors there, right? So sensors are electronic devices or small electronic circuits that are embedded into devices to capture information and send them to a central system. Okay, so sensor technologies started in the military. Okay, the military wanted to have a better idea of the battleground, so they came up with these sensors that they sent to the battleground. So they dispersed these sensors in the battleground, and they could read information and understand more about the situation, right? And then this moved to other areas as well. So Fitbit is an example, and other wearable devices like Apple Watch and all of these nice things. Your smartphone is an example. In healthcare, we have many wearable devices that you can use to measure blood pressure, to measure oxygen levels, and so on. In industry, sensor technology in industry is heavily used to detect defective items, to detect problems, especially in car development and car manufacturing, to detect errors and problems in the car, and so on and so forth. So sensor networks or sensor technology means creating small circuits or small chips and embedding these chips into objects or embedding these chips into um, locations so that we can receive information from this object or from this location. Okay. In business, as I mentioned, they are heavily used in manufacturing and in finding defects um, in merchandise or in products. They are used. We use them all the time. Wearable devices, Fitbits, and so on. We use them all the time, and in smartphones. The biggest problem with sensor technology is security and privacy, right? So if you have a Fitbit, who knows, maybe someone will hack into your Fitbit and be able to read your personal private information. If you have a smart car, sensor and technologies are used in smart cars as well to sense what's going on around them. If someone hacks into your car and plays around with your sensor technology, what will happen to your car, right? This is the biggest challenge. The biggest challenge is privacy and security. This is the biggest challenge here. Right? That takes us to one of the hottest topics right now, which is cyber security, and the counter of cyber security is cyber terrorism. Right? So this is a very big topic, and again, this is one of the. It looks like information systems is a very hot topic everywhere, but cyber security has been big for a while, and it will continue to be big. And because people always find new way to hack into systems and to make cyber attacks against phones, against websites, and so on. The problem with cyber security is the more technology we have, the more problems we get, right? So first we had websites, and people only hacked websites, so they could hack the website by finding the password or by other means, and they can get access to your website. Okay, so we increased the security on our websites. We are using technologies like firewalls, like physical security to protect our systems. But now we have smartphones, right? Smartphones created a whole new area of hacking, right? So now people can hack into your phone, read your messages, operate your camera, do lots of things with your data. Okay, so we increase the security on smartphones. So now we have sensors and sensor devices and smart cards. People can hack into these systems and modify them. So there is always a fight between cyber security and cyber terrorism, always. And I think it's going to continue in the future. As we get more technology, we are going to get more cyber terrorism. And even now with cryptocurrency, some hackers are able to look into cryptocurrency exchange companies and steal billions of dollars of cryptocurrency, and no one knows them because cryptocurrency is pretty secretive. We'll talk about that again towards the end of this course, right?
Anonymous?
Yes, cybersecurity by default is anonymous. So if I steal your money, you won't know what hit you. You won't know who stole your money. It's gone forever, right? That's a big problem in cryptocurrency. Cryptocurrency is anonymous, so anonymous that you don't know who owns the money. You only know their address or some secret thing about them, and that's it. Again, I will talk more about that when we talk about blockchain later on, hopefully, if we have time. Right? Nanotechnology is something, maybe it's not strongly related to business right now. It's not heavily used in business. It's more used in industry more than business. So I won't talk a lot about nanotechnology. Quantum computing. Quantum computing, again, it's still in development. So we don't have a big working quantum computer right now. Quantum physics or quantum mechanics, if you don't know it, quantum mechanics depend on manipulating or using the physics of small objects, so electrons and subatomic parts, and using these to in different applications. So quantum computing depends on using some features of subatomic particles in order to improve the efficiency of computers. Okay. Again, I don't want to dig deep into the technology behind this. I don't want to dig deep into the technical aspects of quantum computing because it's related to physics more than IT and um, uh, and quantum mechanics. So I won't dig deeper into spinning electrons and why the difference between quantum and traditional computing. So I won't deep into this. But what I want you to know is quantum computing uses the features or properties of subatomic particles to improve the performance of computers by millions of times. So it's expected that a small computer like the PC I'm on right now will work like a supercomputer, will work like a huge computer within 10 years. Okay, so it's in progress right now, and many big companies. Google has a project for quantum computing. I think Facebook has one. IBM for sure has one. So there are many big IT companies in the world right now. They are trying to build their quantum computers, but I don't see this happening. Maybe 10 years from today, maybe, but not for now. Right? All right. So searching the deep web, I will talk about that when we moved and talk about text analytics. We have a good part about text analytics as part of this course. So I will talk more about searching at this deep web and the technologies we use when we get there. Okay. Right.